Now let us discuss the topic single phase half wave converter with RL load. So in the previous video already I have discussed single phase half wave converter with R load. So we come to know that the output voltage and current waveform they will be in phase with each other. Now here the load is RL in nature with a single thyristor, and input voltage is going to be sinusoidal, so that is Vs equals to Vm sin omega t. So the supply voltage waveform, so I have represented 2 cycles here, 0, pi, so it is reaching 0, 2 pi, it is completing its full cycle, 1 cycle, and 3 pi, so it is getting negative value, negative half cycle, again after 4 pi the second cycle is also closing. So here, since it is half wave controlled converter, we are providing the trigger pulses only during the positive half cycle. Suppose if it is here at this instant alpha, if we are providing the trigger pulse, next the trigger pulse will be provided exactly at 2 pi plus alpha. So suppose if you consider this instant as alpha, at 2 pi plus alpha the next trigger pulse will be provided. So at alpha, at 2 pi plus alpha, 3 pi plus alpha, and so on. So 4 pi plus alpha and so on. So the trigger pulses will be provided for one cycle. So one cycle, one pulse is provided here. So from pi, from the trigger pulse, from the fighting angle alpha, extend the dotted line onto the x-axis of the output voltage waveform. Now how to draw the output voltage waveform? So here, if it is a resistive load, so during the positive half cycle, so thyristor will be forward bias. First it will be in the blocking state till the trigger pulse is given. Once the trigger pulse is given, so it will enter from the forward blocking state to the conduction state exactly at alpha. So then the supply voltage, the output voltage will form the supply voltage as it is if it is a resistive load. But here, due to inductive nature of the load, so now it is not pure resistive load, so inductive nature of the load. So first what will happen during the positive half cycle, when the switch is closed, when the switch is starts conducting, so when the trigger pulse is applied, so the current starts flowing here in this direction. So therefore the inductor charges with this polarity, inductor will charges with plus minus polarity. So therefore instantaneously inductor opposes the sudden changes in the current. Hence after pi, actually the thyristor is reverse biased, so a negative voltage will appear across the thyristor. So but due to the inductive nature of the load, so as the inductor opposes the sudden changes in the current, so therefore it will continue to conduct till an angle beta, which is said to be extinction angle. So from alpha to beta, the thyristor will continue to conduct. Till beta, it will continue to conduct. So if it is a resistive load, so in the previous case, so it was a resistive load. In that case, exactly at an angle pi, the output voltage becomes 0. So automatically after pi to 2 pi, during this interval, the thyristor will be reverse biased. But here in this case, even though the thyristor is reverse biased, due to the inductive nature of the load here, the energy would be stored in the inductor. So therefore, so whatever the energy, so that would be dissipated. So till that dissipation of that energy which was present in the inductor, so inductor will continue. So because of that, so the current will continue till that angle beta, which is said to be extinction angle. So here beta is called extinction angle. Beta is called extinction angle, and hence here I can represent the current waveform as first inductor charges, then the inductor discharges. After pi, inductor, whatever the energy stored in the inductor, it discharges. So first inductor charges during the positive half cycle, during the negative half cycle the inductor discharges. So here during the positive half cycle, whatever the energy from the supply, so it is flowing from the supply to the load here when the inductor is charging. Then during discharging period, what will happen? The inductor polarities will get reversed here. The inductor polarities will get reversed during the negative half cycle. As the during the positive half cycle, the polarities will be like this, and during the negative half cycle the polarities will get interchanged. So similarly, when the thyristor is on, or when the during the positive half cycle, the polarities of the inductor will be plus here, minus here, plus first, minus next, when it is in charging, and during discharging the polarities will get interchanged. So the energy will flow from the load to source. So when the inductor is discharging, the power is flowing in the reverse direction, or from the load it is pumping the energy back to the supply. So we can say that it is going to be the negative power. That is why the output voltage here, it is negative. So a negative pulse is appearing here. So during the interval pi to beta, so a negative voltage is appearing. Hence here during alpha to pi, the power is positive, so power is flowing from source to load. During pi to beta, let me indicate pi here. During alpha to pi, the energy is flowing from the source to load, the inductor is getting charged, and during the negative half cycle, so even though the thyristor reverse biased, but due to the energy stored in the inductor, so which makes the device still to continue in the conduction state, so it is pumping the energy back to the source there, and the same repeats here. Again during the next positive half cycle, when the trigger pulse is applied at 2 pi plus alpha, the output voltage will just follow the supply voltage waveform, and it will continue till the at extinction angle, and during the remaining period the output voltage will be 0 till the next trigger pulse is given at 2 pi plus alpha. And the current would be, first it will be increasing, that is charging the during inductor is charging, again discharging. So like this you can represent the current waveform here. I0 separately, the current waveform would be like this. So the output voltage is appearing between the limits alpha to beta, so it is existing between alpha to beta. So let us derive the expression for the average output voltage. In case of RL load, single phase half wave converter or single phase half wave controlled rectifier, 1 divided by 2 pi integral alpha to beta. So previously for resistive load we have taken it as the limits as alpha to pi. Now the upper limit is going to be beta now. So alpha to beta, Vm sin omega t d omega t. Taking Vm outside, Vm divided by 2 pi integral of sin omega t, it is going to be minus cos omega t. The limits are between alpha and beta. The higher limit is going to be beta, lower limit is going to be alpha. Vm divided by 2 pi. So minus cos beta, minus of minus, plus cos alpha, or I can rearrange. So cos alpha minus cos beta. So Vm by 2 pi cos alpha minus cos beta. So if you want to get the average output current, I0 equals to Vm divided by 2 pi r, applying Ohm's law, so I equals to V by R. So average output voltage expression we do have. So divided by that, divided by resistance. So for that output voltage expression, we will get the output current, average output current expression. So which is given by Vm by 2 pi r cos alpha minus cos beta. Just similar to the case of resistive load. So let us try for the RMS value of the output voltage. V0 RMS equals to 1 divided by 2 pi integral. The limits are between alpha to beta, Vm square sin square omega t d omega t under square root of 1 divided by 2 pi. The limits are from alpha to beta. So already this derivation we have done for resistive load. The term is going to be the same. So let us, only the limits will be changing. So taking Vm outside, Vm divided by square root 2 pi. So sin square omega t, so we can write it as 1 minus cos 2 omega t by 2. The limits are between integral alpha to beta. So d omega t whole to the power of, I am trying to write whole to the power of 1 by 2. That is equals to Vm divided by square root 2 pi. So d omega t by 2 minus sin 2 omega t by 2 already 2 is there, so 4 sin 2 omega t by 4. The limits are between alpha to beta whole to the power of 1 by 2. So Vm divided by square root 2 pi. So here upper limit is going to be beta minus alpha by 2 minus sin 2 beta minus sin 2 alpha divided by 4 whole to the power of 1 by 2. So here in the previous case we got sin 2 pi, so the term becomes 0. Now here the upper limit is going to be beta here, so we cannot make it 0. Minus sin 2 beta minus of minus plus sin 2 alpha, it will become sin 2 alpha. And taking 2 outside from the denominator, Vm divided by 2 root pi, if you take out beta minus alpha divided by 2, so minus of minus plus sin 2 alpha minus sin 2 beta divided by 2 whole to the power of 1 by 2. So here since we have taken out 2 outside, so it is only beta minus alpha plus half sin 2 alpha minus sin 2 beta to the power of 1 by 2. Or finally I can write it as V naught RMS equals to Vm by 2 root pi beta minus alpha plus half sin 2 alpha minus sin 2 beta whole to the power of 1 by 2. RMS value of the output voltage. So here, due to the inductive nature of the current, inductive nature of the inductor, here current will not become 0 at an angle phi here. So current continue to conduct till the extinction angle beta here. That makes the difference here. So power flows from source to load from alpha to pi, and pi to beta power, the power will be sent back. So the energy flows from the load to the a part of the energy flows from load to the source during this interval phi to beta, whatever the energy stored in the inductor. So till that inductor dissipates, till that period, so the current continue to extend. So that's why it is known as the extinction angle. So extinction angle. So actually it has to stop the conduction at pi. So it happens only in resistive load, since inductor doesn't allow the sudden changes in the current. So current suddenly cannot become 0 here. So even though the thyristor is reverse biased here, so due to inductive nature of the RL load here. So RL load, since the inductor is present, so during the negative half cycle here minus sign and plus sign here, plus sign, minus sign and plus sign here. So whatever the voltage here, so still makes forward bias. So it will the potential here and the potential here supply side. So the potential of that inductor would be more than the supply side voltage. Because of that, the device will be still in the conduction state. So it will continue till that extinction angle, so that when the energy completely becomes 0 in the inductor, then thyristor goes to off state. Thank you.